Right? Now we'll see the next question, variable separable method. Variable separable. Of solving differential equation. I told you, to identify this part, we need to know first it is of the variable separable method. Okay, now see here, solve the differential equation dy by dx is equal to 1 plus x square plus y square plus x square y square. Given y is equal to 1 when x is equal to 0. Okay, now see this question, first order first degree verse and x and y are separable. So this comes under, this is the clue for this. So variable separable method. Okay, right? So in this case, what we proceed with? So we go with dy by dx is equal to 1 plus x square 1 into plus y square into 1 plus x square, which comes to be 1 plus x square into 1 plus y square. This is dy by dx. Now variables are separated. Dy by 1 plus x square is equal to 1 plus x square dx. So tan inverse y plus c1 is equal to x plus x cube by 3 plus c2. Implies tan inverse y is equal to x plus x cube plus c. So when x is equal to 0 and y is equal to 1, okay, tan inverse 1 is equal to 0 plus 0 by 3 plus c implies c is equal to pi by 4. Therefore, tan inverse y is equal to x plus x cube by 3 plus pi by 4 is the solution of the given D. This is what is got the particular solution. So note down. Okay, clear? Very simple question. You are able to identify it as the first order, first degree, and x and y are able to be eliminated. Then automatically it comes under variable separable method. Okay, next question. Find a particular solution. So when particular solution given, automatically it was meant that you are given x and y values of the differential equation e power x into root of 1 minus y square into dy dx plus y by x dy is equal to 0, given that y is equal to 1 when x is equal to 0. Again, you can see the given differential equation is e power x into root of 1 minus y square into dx plus y by x dy is equal to 0. So e power x into root of 1 minus y square dx is equal to minus 1 by x dy. So dy by dx is equal to e power x into root of 1 minus y square into x by minus y. That implies y dy by root of 1 minus y square is equal to minus e power x into x dx. So minus 1 by 2 minus 2y. Okay, multiplying with the 2 and dividing with 2. Here 2, here 2. So 1 integral 1 by 2 root x is equal to root x. So minus root of 1 minus y square is equal to minus integral of e power x into this is u is equal to e power x, e is equal to x, v is equal to e power x. So integral u v dx is equal to u into integral v dx minus integral of u dash integral v dx whole dx. So u into x into e power x minus integral of 1 into integral e power x dx whole dx. That is equal to minus root of 1 minus y square is equal to minus x e power x plus e power x plus c. At x is equal to 0 and y is equal to 1. Okay, 0 is equal to 1 plus c, that implies c is equal to minus 1. Hence, x e power x, x into e power x minus 1 minus root of 1 minus y square is equal to 1 is the particular solution. R plus 1 is equal to 0. Okay, because c is equal to minus 1. Right? You got next question? Next question. Here plus one, you know. Minus minus will become plus. Next question. Find the particular solution of the differential equation. X minus y into dx plus dy is equal to dx minus dy given that y is equal to minus 1 when x is equal to 0. Given differential equation is x minus y into dx plus dy is equal to dx minus dy. So x dx plus x dy minus y dx minus y dy is equal to dx minus dy. So x dx minus y dx minus dx is equal to y dy minus x dy minus dy. So dx into x minus y minus 1 is equal to dy into y minus x minus 1. Okay. Is it in here? Okay. We can't get like this. So what comes here? So dx plus dy is equal to dx minus dy by x minus y. Integrating both sides. Integrating both sides. Integral dx plus dy is equal to integral dx minus dy by x minus y. Put x minus y is equal to b. Implies dx minus dy is equal to dt. So integral dx plus integral dy is equal to integral 1 by d dt. X plus y is equal to log mod t plus c. At x is equal to 0 and y is equal to minus 1. 0 minus 1 is equal to log mod t plus c implies c is equal to minus 1 minus log mod t. That is equal to minus 1 minus log mod x minus y, which is equal to minus 1 minus log 0 minus log minus 1, which is equal to minus 1 minus log 1, which is equal to minus 1. Therefore, particular solution is x plus y is equal to log mod x minus y minus 1. Or one you can take this side, no problem, no difference. Okay, noted? Yes. Now we'll continue. Solve the differential equation. Solve the differential equation e power x into tan y dy plus 1 minus e power x into secant square y dy is equal to 0. Right? Here dx. That implies e power x into tan y dy is equal to minus of 1 minus e power x into secant square y dx. dy by dx is equal to e power x minus 1 by e power x into secant square y by tan y. So tan y here dx, here dy. So e power x by 1 minus e power x into tan y by secant square y. So tan y secant square y by tan y dy is equal to e 1 minus e power x dx by 1 minus e power x. So minus e multiply, minus e multiply. That implies log mod tan y is equal to log mod 1 minus e power x plus c. At x is equal to okay. Log mod tan y by 1 minus e power x is equal to c implies tan y by 1 minus e power x is equal to e power c, which comes to be tan y is equal to 1 minus e power x into c. So y for is y is equal to tan inverse 1 minus e power x. That's the solution. Into c. Okay, that is the answer. question. Okay, clear, understood. Next question. Next question. Next question. If y of x is a solution of two plus x sin x by 1 plus y. Into dy by dx is equal to minus cos x and y of 0 is equal to 1 then find the value of y of 5 by 2. So y of x is a solution. So you have to get the solution in terms of y of x. Okay? So given dy by dx is equal to minus cos x into 1 plus y by 2 plus sin x. So dy by 1 plus y is equal to the cos x minus cos x dx by 2 plus sin x. So t is equal to 2 plus sin x, dt is equal to cos x dx. So here integral, here integral. So minus will come up. So log of 1 plus y is equal to minus log mod 2 plus sin x plus c. So y of x is the solution. Okay. So you can write as log of 1 plus y plus log of mod 2 plus sin x is equal to c. I can write as log c because since c is equal to log c, we can use this phenomena, we can use this relation, this conversion anytime when logs are there. Logs are there. So you can use this c as log c, you can write anytime. When logs comes now, c you can write log c because both are constants only. So you can remove the log both at a time. Understood now? So whenever we are using c as log c, when there is other log is there, c you can take as log c. Otherwise e power c will come, right? Now you can write as log of 1 plus y into 2 plus sin x is equal to log c. So 1 plus y is equal to c by 2 plus sin x. Now f of y came. It is f of y. 1 plus y means it is f of y. Therefore y is equal to c by 2 plus sin x minus 1. Now y of 0 1 means implies what you can write? That x is equal to 0, y is equal to 1. It is understood. Y of 0 means y of x only. So at x is equal to 0, y is equal to 1. It's okay. Therefore, at x is equal to 0, comma y is equal to 1. 1 is equal to c by 2 plus 0 minus 1. So c is equal to 2 plus 1 which is equal to 3. Therefore, y is equal to 3 by 2 plus sin x minus 1 is the solution. Also y of 5 by 2 is asking. So y of pi by 2 how will get? Y of pi by 2 means implies that x is equal to pi by 2. Four. Okay, 2 plus 2, 4 again, sorry. 4 will come here. Y by 2 means y is equal to 4 by 2 plus sine pi by 2 minus 1, 4 by 3 minus 1 which is equal to 1 by 3. Okay. This is the solution. Okay, clear? No down. Are you clear now? Okay, next question. Understood now clearly? So whenever logs comes, now C you can write as log C. That is standard. You remember it. To remove the log at a time, to apply the log at a time, we use this phenomena. Okay. Next question. Next question. So our derivative is equal to cos x plus y plus sin x plus y. Right? Now put x plus y is equal to z. So dx plus dy is equal to dz. R1 plus dy by dx. Right? Dz by dx. On substituting these values, on substituting these values in equation 1, dz by dx minus 1 is equal to cos z plus sin z. That implies dz by dx is equal to cos z plus sin z plus 1. Therefore, integral dz by cos z plus sin z plus 1 is equal to integral dx. Implies dx by 1 minus tan square z by 1 plus tan square z plus 2 tan z by 1 plus tan square z plus 1 is equal to integral dx. Since what the rule? Since sin z is equal to sin x is equal to 2 tan x by 1 plus tan square x by 2, z by 2, z by 2, z by 2, z by 2, and cos x is equal to 1 minus tan square x by 2 by 1 plus tan square x by 2 is the formula. Right? Now we'll go for LCM. That implies dz by 1 minus tan square z by 2 plus 2 tan z by 2 plus 1 plus tan square z by 2 by 1 plus tan square z by 2. Is equal to integral dx. This is tan square z by 2 cancel. 2 plus 2 tan z by 2. That implies 2 into 1 plus tan z by 2 by 1 plus tan square z by 2. Okay, dz is equal to integral dx. So 1 by 2 integral secant z secant square z by 2 dz by 1 plus tan z by 2 is equal to integral dx. If t is equal to tan z by 2, dt is equal to half secant square z by 2 dz. Okay, so that is equal to integral 1 by t dt is equal to integral dx. Log mod t is equal to x plus c. So log mod 1 plus tan z by 2 is equal to x plus c. Again, z you have to substitute. Because z is equal to, okay, since z is equal to x plus y, okay, what you can take now? Log mod 1 plus tan x plus y by 2 is equal to x plus c is the solution. This is the third part. This is the second part. Okay? Likewise. So this is an indirect question in terms of variable several. It looks to be because sin and x plus y are with plus and minus, na, it looks to be non case of variable separable, but it is variable separable only. So this is a question is very important. Like this is a hard question from example problems, right? Next, homogeneous linear. Okay, noted. We'll do one more question like this. Next question. Solve the following differential equation. Sin plus d by x is equal to x plus y. Right? Implies sin x plus y is equal to dy by dx. Put x plus y is equal to z. Right? Therefore, 1 plus dy by dx is equal to dz by dx. Now this part implies dy by dx is equal to dz by dx minus 1. That implies sin x plus y is equal to dz by sin z dx minus 1. That implies 1 plus sin z is equal to dz by dx. That implies integral dx is equal to integral dz by 1 plus sin z. Right? By taking the variable and separable. Now, sin z is equal to 2 tan z by 2 by 1 minus tan square by 1 plus tan square z by 2. Therefore, so integral dx is equal to integral dz by 1 plus 2 tan z by 2 by 1 plus tan square z by 2. That is equal to integral dx is equal to integral 1 plus tan square z by 2 by 1 plus tan square z by 2 plus 2 tan z by 2 dz. Integral dx is equal to integral secant square z by 2 dz by 1 plus tan z by 2 whole square. If t is equal to 1 plus tan z by 2, then dt is equal to secant square z by 2 into half. That implies integral dx is equal to half integral half secant square z by 2 dz, okay, by 1 plus tan z by 2 whole square. That implies integral dx is equal to half integral dt by t square. Okay, dz here. That is implies integral dx is equal to minus integral 1 by 2 integral minus 1 by t square dt. Now again you can go. So x is equal to minus half into 1 by t plus c. X is equal to minus 1 by 2 into t means x plus y. T means 1 plus tan z by 2. X is equal to minus 1 by 2 into 1 plus tan of x plus y by 2 plus c. Is the required solution. Hold on. Okay, right? Like this you have to proceed. That you can simplify if you want, but I think it is not required more than that. You got the solution, no? Enough that was. Right? So likewise, I think we'll proceed now. I think we'll go to the okay, then we'll continue next.